Have you ever typed some totally wild phrase into an AI image generator and just been floored by what it spits out? You know, something like a corgi riding a rocket into a nebula made of cheese. It feels like straight up sorcery, right? But it's actually this incredible dance between chaos and order. So let's pull back the curtain and see how the magic really happens. So you know how it goes. It all starts with a simple prompt from you. You type in a few words, let's say, an astronaut holding a flag. You hit enter and boom, in just a few seconds, a super detailed image just appears out of nowhere. But what is actually happening in that short little moment? How on earth does a machine translate the idea of an astronaut, the concept of a flag, and the action of holding into a coherent picture made of pixels? Well, that's the big mystery we're going to unravel today. And the answer, honestly, is probably not what you're thinking. An AI image doesn't start with a nice, clean, blank canvas. Nope. It starts with this, pure, random noise. Kind of like the static you'd see on an old TV that's not tuned to a channel. And that brings us to the first big idea, the art of denoising. The main job for the AI is to find a signal inside all that noise, to literally pull a clear image out of that digital static. The whole thing is done through a technique called a diffusion process. And to really get it, you kind of have to think backwards. See, scientists trained this AI by taking billions of real, clear images and then slowly, step by step, adding digital noise to them until they were nothing but static. The AI's job was to watch that whole process and learn perfectly how to do it in reverse. So, when you ask for an image, the AI kicks off this journey back from static. With each little step, it makes a tiny adjustment, just chipping away at the chaos. At first, you can barely see anything, maybe a faint hint of some kind of structure, but after it does this dozens of times, a clear, recognizable picture starts to crystallize right out of the noise. Okay, now here is where things get really weird. The researchers who built this stuff found this totally counterintuitive trick. What if, while the AI is in the middle of removing noise, you intentionally add a little bit more noise back in at each step? It sounds like it would ruin everything, doesn't it? Well, you'd be wrong. Without that little bit of extra noise, the AI tends to play it safe, and you end up with a blurry, kind of averaged out image. But by injecting just a little bit of chaos back into the system, you force the model to commit to sharper, more defined details. It's this wild example of how a little bit of randomness can actually lead to a way, way better result. Okay, so the AI has a method for sculpting an image out of pure chaos. But how does it know what to sculpt? How does it connect your words like astronaut with the visual idea of an astronaut? For that, it needs a special kind of map. You can think of it like a digital Rosetta Stone. The AI needs some kind of system that can translate between the language of words and the language of pictures, so it can find the common ground that links them together. That system has a name. It's a model called CLIP. It's basically two AIs working together. One of them is an expert on text. It's read a huge chunk of the internet. The other is an expert on images. It's seen billions of them. Together, they create this shared idea map, this giant conceptual space where the text, a photo of a cat, is located right next to an actual photo of a cat. And the way this map works is it's wild. You can literally do math with ideas. If you take the data point for me wearing a hat, and you subtract the data point for me not wearing a hat, you are left with a vector that points directly to the pure, isolated concept of hat. It's incredible. It's a map of meaning itself. So we've got a way to create images from noise, and we have an idea map that connects our words to those images. Now let's put these two pieces together and see how they guide the whole creative process to make sure we get exactly what we asked for. Turns out, to get those really precise results, the AI needs two sets of instructions. One that tells it what you want, and another that, in a way, tells it what you don't want. It's this push and pull dynamic that's the secret to getting a perfect picture. So here's how that works. At every step of the denoising process, the AI actually generates two sets of directions. The first one is for your specific prompt, let's say a tree in the desert. The second one is an unconditional direction, which basically points toward the most generic, average, blurry image imaginable, the concept of nothing in particular. And then, just like we saw with that hat example, it does some really simple math. It takes the tree in the desert direction and subtracts the generic direction from it. And what's left over is the pure, unfiltered essence of your specific prompt. And here's the final brilliant move. The AI takes that pure direction and it amplifies it. It basically turns up the volume on your specific request. This technique is called classifier-free guidance, and it forces that whole denoising process to pay really close attention to exactly what you want. And you can literally see this amplification in action. At a low guidance scale, the AI is barely listening to your prompt, and you get something vague. But as you crank that scale up, it starts paying much closer attention, and the image becomes way more detailed and accurate. It's basically a volume knob for creativity. So let's just take a quick step back and put all these pieces together. We've gone from total chaos, from pure static, to a precisely guided, finished creation. I mean, this isn't just a new tool, it's a completely new kind of digital canvas. So if you're going to remember anything, remember these three pillars. First, creation from chaos, starting with random static and sculpting it into an image. Second, an idea map, using a model like Clip to actually understand what you're asking for. And third, precise guidance, amplifying your prompt signal to steer the process with incredible accuracy. So yeah, while the results can absolutely feel like magic, the process itself isn't. It's just this incredibly elegant and clever combination of ideas from physics like diffusion and this groundbreaking work in mapping the very relationship between our words and our pictures. And all of this leaves us with a really fascinating question. For pretty much all of human history, visual art required physical tools and years of practice. Now, the only tool you need is language. So what does the future of creativity even look like when the only real limit is your own imagination?